Hi. What we're going to do is we're going to look at how we can use the unit circle to produce a graph of the sine of a certain angle. So we have a unit circle here, which means that our radius is 1, and here's our angle. So as our point P moves around, so as our angle increases, we can look at the y coordinate of that point on that unit circle, and that's going to give us the sine of the angle, the sine ratio of the angle. So at 0, our y coordinate is 0. At pi on 2 radians, our y value, our sine of the angle is going to be 1, down to 0, down to -1. So what I have here is a cool little applet from www.desmos.com that I'm going to use to demonstrate that as we increase our angle around our sine curve, we can trace the sine function. So here we have our angles increase, and remember the sine is going to be our y coordinate. So we started off at 0. At pi on 2 radians, we're going to meet our maximum amplitude. So in this case, because it's a unit circle, it's going to go up to 1. All the way back down to pi is going to be 0. At 3 pi on 2, we're going to be down to -1, and then back up to 0 at 2 pi. And that function will continue to increase like that. We'll just go on. Now, what we also want to do is have a look at, we're not always going to have a maximum amplitude of 1. It's going to depend on our units. So our amplitude can increase and it can decrease. And our next thing is to look at what that's going to look like in our function. Our top function here is a basic sine curve function, so y equals sine of x. And we can see that it has a period of 2 pi, so that means at every 2 pi radians, or 1 full revolution, it's going to repeat itself. And we've got an amplitude of 1, which means it goes up to 1 and down to -1. So the maximum distance from that midline around which it oscillates is going to be 1. Let's look at our next graph. This one is going up to 3, 0, down to -3. So it's got an amplitude of 3. So you can see that in your sine function that y equals 3 sine x. So this value here is what's going to tell us our amplitude of our graph. In our next video, we'll have a look at some of the other aspects of how we can manipulate our basic sine graph.